Hi everyone, my name is Matthew Tam and I will be presenting the paper titled Integration of Parametric Structural Analysis in Architectural Design Using a Novel Approach to Enhancing Timber Compression Elements. My co-authors are Florian Fend and Clemens Preisinger. The research centers around a series of information pavilions which were completed in 2020 for HOLZWELT Murau. It was a collaboration between Florian Fend and the students at the Institute of Media and Architecture at the Technical University of Graz, along with Clemens and myself who are working at the structural engineering practice Bollinger+Grohmann in Vienna. Just to situate ourselves, these stands are located in Murau, which is in the alpine region of Austria. It lies in between Graz and Salzburg, which is approximately 3 hours by drive from Vienna. This presentation will be split into three main parts. First, we will concentrate on the workflow starting in the winter semester of 2018, when the master students were tasked to design an information stand using timber as the main material focus. Then we will dive into the structural analysis procedures that were performed during the project development. This was based on the original design of the students and the prototype that they built. Lastly, we will look at the fabrication and assembly process to be able to realize these 9 pavilions. As mentioned, this research kicked off as a design master studio in 2018. The students performed many material, digital and physical studies before one project was chosen to prototype at 1:1 scale. This project was titled Twist. It had a simple yet strong concept of twisted lamellas, spanning between 2 horizontal timber panels to delineate walls. During the semester, the students also had to grasp various topics of digital design, fabrication, as well as an understanding of structural systems and timber mechanics. Close collaboration of experts in the respective fields enabled the students to better understand these rather complex issues that we often face in our industry. The students met the challenge set out at the start of the studio with the completion of the built prototype in 2019. The client, HOLZWELT Murau, were very pleased and commissioned the construction of the 9 pavilions. Florian then led a small team of students and worked closely with us at Bollinger+Grohmann to establish an efficient workflow to meet the design criteria for the final 9 pavilions. They experimented with 3D models in Runner 3D, which could be easily fed into Grasshopper. A parametric setup enabled us to quickly take design iterations and perform quick structural analysis in the finite element toolkit Parametric 3D to get some initial feedback on its performance. Then, detailed code checks were performed using RFM. These are the 3 typologies that were finally selected. Each of them reacts to different criteria on the given site, such as functionality, orientation, as well as external loads. They are composed of the same basic kit of parts, which includes concrete pedestals for the base plate to sit on, a series of wall-like twisted lamella elements, several vertical panels for displaying the information, and a horizontal roof panel. The innovative construction principle in this research are the twisted wooden lamellas. These act as the structural elements for the vertical load takedown. By twisting the lamellas that are held between fully fixed supports, the buckling length can be reduced to up to 30% as compared to straight elements. This is due to the fact that in the case of straight elements, the bending stiffness about the weak axis governs the buckling load limit, whereas the potential buckling resistance of the strong axis remains unused. Twisting the beam and cross-sections with respect to each other varies the orientation of strong and weak bending axis along the element, and thereby affects the reduction of buckling length. In digital simulations of individual members, 3 points of inflection start to emerge at smaller distances in an element twisted at 30 degrees, whilst in the straight element these zones lie at a distance of approximately half the total beam length. Full-scale tests were performed on twisted lamellas at the technical school in Murau. These tests showed that a 40 mm thick, 20 cm wide, and 3 meter tall lamella with a torsional angle of 70 degrees were able to withstand a total weight of approximately 140 kilograms before the elements started to buckle. The location of the 9 stands played a huge role in influencing the design. During the structural analyses, it emerged that the combination of wind and load were the governing load cases. The remote location of Turakahura, for example, sits at approximately 1800 meters above sea level. It has a characteristic snow load of 7.3 kilonewtons per square meter and a maximum wind speed of 140 kilometers per hour. In the calculation model of the lamellas, an elastic plastic load-bearing behavior was assumed. This led to a redistribution of normal forces in the structure. The analysis showed that the pre-stress in the twisted elements actually disappears after a while, but has no impact on the reduction of the buckling length. A subsequent design check with respect to Eurocode 5 ensured a sufficient material safety. It was decided at the beginning of the design phase that the timber elements would be entirely prefabricated remotely and transported to the subsequent sites. This meant the design of the typologies involved either splitting into multiple parts or maximizing them to the extent of transportable dimensions. The concrete pedestals and foundations were poured on site and the timber part was then mounted above. The pivotal point of the analysis was the assumption of fixed boundary conditions of the lamella elements. This meant that the design of the connection details needed special attention. The lamellas are slotted through the roof panel, sanded down and fixed with screws, whilst in the base plates, Loctite pure bond was used to help alleviate the fact that these connections would be more exposed to moisture. All of the horizontal elements were CNC'd with a tolerance of 0.2 millimeters. As the timber itself was quite dry during the fabrication process, it is expected that this has now expanded over time. The vertical elements are not treated additionally, but the horizontal elements were coated with a simple wood oil. The success of his research is manifested in the completion of the 9 INFOSTANDs in the late summer of 2020. This is just a snapshot of 3 of them which sit elegantly amongst the landscape and urban environment. We invite you all to come visit the region and explore these magical pieces of innovative timber construction. Thank you all for your attention.